Hey guys, welcome back to the Calculus Guy YouTube channel. Today in this video we'll be learning some of the important concepts related to differentiation, and we will also discuss some of the formulas which will help us to solve the questions related to differentiation. So let's begin. So we will start off with the very basics such as the notation for differentiation is d over dx. It could even be d over dy or d over du. But the thing that we have to remember is in this case we are differentiating the given function with respect to x. In this case we are doing it with respect to y, and in this case we are going to do it with respect to u. Alright, so the first rule that we are going to study is known as the power rule. In this rule we are given a differential such as d over dx, and we have to differentiate x to the power of n. To solve this we have to just remember its formula, that is n x to the power of n minus 1. If you look carefully, the thing that we have done is we have bring this n on the top to the front and subtracted 1 at the top. So if we take an example such as d by dx of x to the power of 4. So the thing that we have done is bring this 4 in the front and subtract 1 from 4, which is 4 x to the power of n minus 1, which is 4 minus 1, which will lead us to 4x cubed. If we do another example, d by dx of x to the power of 12, it would be bring this to the front, which is 12 x to the power of subtract 1 from the top, n minus 1, which is 12 minus 1, which would lead us to 12x to the power 11. It's that simple. Alright, so the next thing that we are going to study is that the differentiation of any constant number or anything is always 0. So like if we take an example, if we differentiate any number such as 4, it will give us 0. Another example would be if we differentiate any number like 10,000 or any other number that you want, the answer will always be 0, because the identity says that the differentiation of constant will always give us 0. The third important identity is if we differentiate something like this, there is a constant and behind it there is a function, what will happen? So the thing that we have to remember, if there is a constant attached to a function in a given differentiation question, you just have to take this constant out and directly differentiate this function. So like for example, you are given a question such as d by dx of 4x cubed. Let's assume this question. So the thing that I have told, bring this constant out and directly differentiate this function, which will give us 4 d by dx of x cubed. So now the final answer gets 4, and using the power rule that we have learned earlier, this would be 3. This comes forward and x to the power of 3 minus 1, which is 4 into 3 x squared. So the final answer is 12x squared. Alright, so the fourth property that we are going to learn here is very important. If we are given to differentiate two functions like u into v, two different functions are multiplied with each other and we are told to differentiate it, then we have to remember this simple identity, which is u differentiation of v plus v differentiation of u. Alright, so the fifth identity is if you are asked to differentiate those two functions that were in multiplication but this time they are in division, what will you do? So we also have a simple identity for it, which is v differentiation of u minus u differentiation of v over v squared. We have to remember this as it is. We cannot change these two, or their places can be changed, so we have to remember this formula as it is. Alright, so now we are left with just some simple formulas that we have to learn, which is differentiation of log x is equals to 1 over x. We have to remember this. Then the differentiation of e to the power x will always be e to the power x. If you differentiate this function like 100 times continuously, you will receive e to the power x as your final product. So whenever you see e to the power x and you have to differentiate it, just directly write e to the power x. Now the eighth identity is d by dx of a to the power x. it is constant to the power of variable. So the formula for this is a to the power x ln a. If you want to see how this formula came, just write it in the comment box. In the next video, I'll just show the derivation of how we got this answer. We have one more similar identity such as d by dx of x to the power x. So the answer would be x to the power x 1 plus ln a. Its answer can also be derived similarly to that which is done here. If you want it, just write it in the comment. I'll do it in the next video. These two requires derivation and a little bit knowledge of logarithm functions. Alright, so now we are left with trigonometric functions and just one rule, that is the chain rule, which we'll learn at the end. So now we have to learn all these trigonometric functions that I'll be writing right here, such as sin x, cos x, tan x, cot x, cosec x, sec x. Alright, so these 6 trigonometric functions, we have to remember all the derivatives. So on the right side, I'll be writing the derivatives of all these functions. So just write them in your notes or just take a screenshot for it. The differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Differentiation of tan x is sec square x. Differentiation of cot x is minus cosec square x. Differentiation of cosec x is minus cosec x, cot x. And the differentiation of sec x is sec x tan x. You will have to remember it. There is no other choice for this. But once you remember all this, you will be very efficient in solving questions. So next that we have is inverse trigonometric functions. This is the last 6 formulas that you will have to learn, and after that you will be done. So like you have been told to differentiate inverse functions like sin inverse x, cos inverse x, tan inverse x, cot inverse x, cosec inverse x, and sec inverse x. So now on the right side, I'll again be writing the differentiation for all this. So sin inverse x is 1 upon under root 1 minus x squared. For cos inverse x is minus 1 upon under root 1 minus x squared. For tan inverse x is 1 upon 1 plus x squared. For cot inverse x is minus 1 upon 1 plus x squared. For cosec inverse x is minus 1 upon modulus x under root 1 minus x squared. For sec inverse x is 1 upon modulus x under root 1 minus x squared. All these might look very complicated, but if you see the sin x formula, for cos x it's just negative, the tan x and the cot x is just negative of that, sec x and cosec is just the negative of that. Alright, so the last thing that we have to learn is the chain rule. In the chain rule, it is a very vast topic, but I'll just summarize it up for you. So in the chain rule, if you are given any function like sine of x squared and you are told to differentiate this function, so now what will most of the people do? They'll just think that we have learned before that the differentiation of sine x is cos x. Yeah, but this is wrong. There is an x squared here, so most of the people might even put x squared here. But the chain rule says that once you differentiate this entire function, you will also have to differentiate this function once again to get your final correct answer. So like the differentiation for x squared using the power rule would be 2x. Like x squared, so like 2 comes forward and x to the power of n minus 1, which is 2x. So this is the chain rule. It is it can go very complicated as well, but just remember, if you have this like complex function in which 2 things can be differentiated and sometimes 3 things can also be differentiated. So the differentiation for sin x we wrote cos x, and then this function we also differentiated once again and write 2x here. So the final answer would be 2x cos x squared. Make sure to put brackets here or else the teacher might get confused. Alright, so the chain rule is this. So the thing that I want to show, if we have d by dx. So remember, this function is going to be differentiated with respect to x. Okay. So now if there is sin x here, you can directly write cos x. You just have to remember the formula for it. But now if you think d by dx, if it's sin y here, what you'll do? Because we are going to differentiate this function with respect to x, but the function here is with respect to y. So what you'll do? So it's very simple. You'll just have to apply chain rule here. So remember, sin y, the differentiation of sin y would be cos y. We learned it because sin x is cos x, so sin y will be cos y. So it would be cos y. And now this y will be differentiated once again with respect to x, which would be dy by dx. Now you might be thinking why we didn't do this same thing on the top as well. So like if you think carefully and now use chain rule here as well, you will use, it will be x here, and you will differentiate this x with respect to dx, so d over dx. So this will cancel out and be 1 itself. So 1 times cos x will be cos x only. You can apply chain rule everywhere. But like in this question, you will have to see that this is with respect to y. So we wrote dy by dx. But in the case here at the top, it is sin x. So if we differentiate x with respect to dx, it will be always 1 as we saw here. So that's all. Most of the important concepts about differentiation have been completed in this lecture. If you have any doubts related to any of the concepts, you can just comment down in the comment box. I'll just share it in the next video at the end of the next video so that you'll have your doubts cleared as well. Thank you, and please don't forget to subscribe our channel. It means a lot to us.